So when an equation has k in it, you're going to use a couple steps to find out what k is in an equation. So for this one, we know that if you divide it by x minus 3, you're going to have a remainder of 1. So what we can do is we can put in 3 for each x, like this, and we know it equals 1. So you can simplify this to 64 plus 3k equals 1, and then 3k equals negative 63. And then we can know k equals negative 21. And now step 3, you're going to use synthetic division, which we just reviewed, to get this. And you can bring this down and write this equation. And then you can simplify this again and get k equals negative 21. And so that's a good, easy way to check your work here. And so that's how you find k.
All right. Now we'll learn about standard form and vertex form and how to change them one from the other. So for standard form, it's the quadratic formula, which is y equals ax squared plus bx plus c. So a, b, and c cannot equal 0, and the y-intercept is 0, c. So it'll be the c value in the standard form. So vertex form is y equals a times x minus h squared plus k. And h comma k is the vertex, where h is an x value and k is a y value. A does not equal 0, but it is the same a as it is in the quadratic formula, so these two a's are exactly the same. But you will need to know the formula x equals opposite of b over 2 times a for vertex form, and that is equal to h as well. So we'll look at an example for standard form real quick. Okay, so for standard form, we'll do vertex to standard. So the equation is y equals 2 times x plus 3 squared minus 22. Now our goal here is to find standard form as well as the y-intercept, a, b, and c, and the vertex. So we will distribute and multiply. So we'll basically just be expanding this. So it'll be 2 times x squared plus 6x plus 9 minus 22. And then we'll distribute the 2, so 2x squared plus 12x plus 18 minus 22. And then you can subtract 18 from 22 and get y equals 2x squared plus 12x minus 4. And now we know that the vertex is at negative 3, negative 22, which we knew originally because h comma k is equal to the vertex. A is 2, b is 12, and c is negative 4. And the y-intercept is 0, negative 4. Now for vertex form, we'll do standard to vertex. So we have y equals 2x squared plus 10x plus 7. So we have to find the coordinate of the vertex first, using the opposite of b over 2 times a. So we'll substitute a and b into the equation from this. So it'll be negative 10 over 2 times 2, and we get that x equals negative 2.5. Then we substitute x into the original equation, so we'll substitute this into this that we just got, and then that equals negative 5.5. So that will be our vertex, and now we can write it in vertex form because we know a from this. So y equals 2 times x plus 2.5 squared minus 5.5. And the vertex is at negative 2.5 comma negative 5.5. A is 2, b is 10, c is 7, and the y-intercept is 0, 7. Now you can try these two equations on your own. Okay. So for this one, we're still changing it from vertex to standard. So you multiply everything out. So you square 4x minus 3 to give you this. Then you distribute the 5 to get this. And then your final answer will be 80x squared minus 120x plus 52. So your vertex will be 3, 7. A is 80, B is 120, C is 52, and the y-intercept is 0, 52. Then for the standard to vertex form, it's y equals 3x squared minus 18x plus 5. So we'll use the opposite of b over 2 times a to get 18 over 2 times 3, which equals 3. And then we'll substitute that in for the x value in this equation, and we'll get that y equals negative 22. So y equals 3 times x minus 3 squared minus 22. And your vertex is at 3, negative 22. A is 3, B is negative 18, C is 5, and the y-intercept is 0, 5.
Alright, finding missing h, k, a, b, and c values. So like the slides before this, you need to use vertex and standard form. The vertex of your graph is going to be hk, which is right here, that's why it's called vertex form. And this has already been gone over, but that's okay. To convert from standard to vertex form and find h and k, you have to use completing the square. And to convert from vertex to standard form and find a, b, and c, you use distribution. Okay, so to go from vertex to standard form, we're going to be using this example equation. First, you need to distribute the square to x plus 3, so you end up getting a quadratic, x squared plus 6x plus 9. And then you distribute the 2 to the quadratic, which you end up with 2x squared plus 12x plus 18 minus 22. And then you add the 18 and negative 22, and you get 2x squared plus 12x minus 4. And if you'll notice, the a value in both the quadratic equation and the vertex form is the same. So a equals 2 right here, 12, or b equals 12, which is right here, and c equals negative 4, since you need to include the minus symbol. Okay, from standard to vertex form, you have to use completing the square. So we're using the same equation, so we should get the same answer. So y equals 2x squared plus 12x minus 4. Since you can take out a greatest common factor of 2, you do that. So y equals 2 times x squared plus 6x minus 2. And then you take half of 6 and you square it, which is the completing the square part. So you get y equals 2 x squared plus 6x plus 9 minus 2. And the reason you do plus 9 and minus 9 is because you're essentially adding 0. So then you take the x squared plus 6x plus 9 part, and you make that into a binomial. So you get y equals 2x plus 3 squared minus 9 minus 2. You add the negative 9 and negative 2. You get y equals 2x plus 3 squared minus 11, and then you distribute the 2. So you should get y equals 2x plus 3 squared minus 22, which is the same thing we have up here. And then in this method, converting to vertex form will help you find the vertex of the parabola, which is hk, so 3 and negative 22. The polynomial remainder theorem is if you take a polynomial and divide it by x minus a, the remainder will equal f of a. So f of x, you divide it by x minus a, and it's going to equal f of a. And then for our example, we have 3x squared minus 4x plus 7 divided by x minus 1. So if we divide 3x squared minus 4x plus 7 by x minus 1, our remainder is going to be f of 1. So for the example, 3x squared minus 4x plus 7 divided by x minus 1, how many times does x go into 3x squared is 3x, which you put right here. And then how many times does negative 1 go into 3x? That is 3x times. So you do 3x times x is 3x squared. 3x times negative 1 is negative 3x. So then you subtract 3x squared minus 3x from 3x squared minus 4x. You get negative x. So how many times does x go into negative x? Negative 1 times. And then you bring down the 7. Negative x squared plus 7 minus negative x plus 1, which is, you get the negative x plus 1 from negative 1 times x and negative 1 times negative 1. And then you subtract that from negative x plus 7, and you get 0x plus 6, which is 6. So 6 is your remainder, therefore f of 1 equals 6. Here's the proof. 3 times 1 squared minus 4 times 1 plus 7 equals 6. 3 minus 4 plus 7 equals 6. Negative 1 plus 7 equals 6, and 6 does equal 6. Alright. Alright, you have reached the end of Unit 2, Part 1 review. The credits, factoring using difference of squares, is Anastasia. Is that how you Okay, is that how you Alright, credits are factoring using difference of squares, Anastasia, factoring using sum and difference of cubes, Anastasia, and behavior of a polynomial, Cooper-Lore. Dividing using long division and synthetic division is Cooper-Lore. Finding k using synthetic division is Cooper-Lore. Finding missing h, k, and b and c values is Aaron-Perry. Remainder theorem is direct substitution is Aaron-Perry. And vertex form and standard form and how to convert between the two is Anastasia.